This is interesting because this seems to be a general trend in data management at the moment, in the sense that when Snowflake came up, they were the ones who invented, in many ways, like decoupled storage and compute, using object storage as the lowest tier. And now you're seeing these, I would say, new age systems kind of using the same underlying principle to disrupt that space. So Rising Wave for streaming, you had WarpStream, which was acquired by Confluent, kind of doing it around Kafka and so on, right? So I think it's super interesting how this dynamic right now is actually playing out throughout the entire data infrastructure stack.
Yeah, we are definitely the first one to build a so-called registry-based systems in the stream processing domain, and we were even earlier than WarpStream.
The Data Engineering Show is brought to you by Firebolt, the cloud data warehouse for AI apps and low latency analytics. Get your free credits and start your trial at firebolt.io.
Hi, everyone, and welcome back to the Data Engineering Show. Today, we're super happy to have on Yingjun Wu, who's the founder and CEO of Rising Wave. Welcome to the show. For those of kind of us, well, I heard of Rising Wave, but for the listeners who haven't heard of Rising Wave and maybe Eldad, do you want to tell us what the system is all about, kind of what you're working on? I think it's super cool, so I'm sure everyone else would love to hear more too.
Sure. First of all, thanks for having me here. And I'm Yingjun Wu, and I'm a founder of Rising Wave. So yeah, people always ask me about, okay, what are you currently working on? Like I would say, okay, definitely, well, what is Rising Wave? Rising Wave is a stream processing system. But this day show a lot of buzzword about Iceberg. We could probably discuss that later. But essentially, we founded a company 4+ years ago, and before that, I was at AWS Redshift as well as IBM Research Armadan. Actually, people sometimes will ask me, okay, why Redshift is like a batch-based data warehouse, right? Well, why you started working on something like stream processing? A little bit history of myself. I got my PhD in stream processing and database systems. So
you had no choice. You had no choice, basically.
and you spent some time in Andy Pavlo's group as well, right? Like who's a previous guest on the podcast. So I love
Guest
how
of
we're
honor.
like connecting. Exactly, former guest of honor, and now we have you as guest of honor.
Yeah, I'm not sure whether we have enough to dive deeper into details, but essentially, I was when I was with Andy Pavlo, we were doing something like transaction processing, and essentially at the time there was a concept called deterministic transaction processing, and basically it's like, okay, reorder the transactions before execution, and essentially the concept is the same as the stream processing, and that's why I have during my PhD, I studied both stream processing and transaction processing because at the time, there was just some concept that linked these two things together. Yeah.
Cool. And then fast forward after your PhD, you said, time to build a new database system.
Yeah, IBM, DBT, right? And Redshift actually at that time was probably 10-year-old. But I feel that's really key. If you look at Redshift, batch-based system, but how about stream processing? Because essentially in Redshift, a large percent of the data is actually was ingested from Kinesis or Kafka, right? And these are streaming data, but there was no stream processing systems. Well, there were some stream processing systems like at the time Spark Streaming, Flink. These are still popular these days, but at the time there was also KCDB and Apache Storm. But I feel that's what these kind of systems were not that easy to use, and there were some fundamental issues with the key concept was called state management. We can probably dive deeper into details, but there were some issues. So I feel that's definitely it's the right time to build something new, and that's why we found a company.
Nice. That's awesome. So tell us about those early days. This is one of those, like building a system from scratch is like crazy daunting challenge, right? Like you need to do everything, like parser, planner, runtime, kind of all of it for streaming system, integrating with storage. Like how long did it take you to get to a first version of the product? When did you launch it? How did your first users like it? Take us through the journey of Rising Wave, basically.
It definitely was a pain. During the first 2 or 3 years, and the issue here that's whenever you started building something, let's say database systems, so very hardcore, low-level systems, data infra system, then essentially it's not about your concept, right? It's not about your let's say so-called design principles, right? Well, it's more about okay how old the system is, and it's more about the trust. If you tell people, okay, my system was just 2 year old, okay, then people will say, okay, that's a new system. That's pretty cool. I will probably take a look at that, and I probably will follow you. But nobody will take it serious, to be honest. And in our case, we did not really have any customers for in the first 2 years, actually the first 2.5 years. And the first POC user was like tiny startups. And we found startup because I mean they actually just startups trust startups because we know each other, and yeah, so they adopted Rising Wave. And I definitely also pitched to Rising Wave to some big companies. So, but what I would say is that, well, okay, like Rising Wave is like a new system, and you do not need to put it into production. Just to use it for in some your test environment because it's so easy to use. We actually have the single binary. And we are Postgres compatible. I mean, Rising Wave itself is not single binary, but we actually made a single binary version just for some customers to self-deploy. Hey, no Docker, yeah, just a single binary, just like DuckDB. So yeah, anyways, for the first 2 years was just like tough. And I think we were definitely blessed for that. We got first a few customers in the year 2.5. Actually, they were, and one of them was like we had at least probably three of them. One of them was like a crypto company. At the time, where they were also a pretty tiny company, but we're actually these days, well, they are still our customers, and they are paying us six figures every year. After they become big, and they grew from a startup to a big company. And the other two are both pretty big companies. When one of them actually a Fortune 500 companies. So I feel that's why it's like just a blast, and we got lucky. But this is why it's like because we have already had a pretty good customer base, and we never need to answer questions like, okay, whether your database system is trustworthy or not, or we just tell we have a page showing our customer logos, and that's it.
Nice, cool. So zooming out a bit, like take us through the current stream processing space, right? Because there's nowadays actually a fair amount of systems. I think like the OG is kind of Flink. That's been around for quite a while. There are systems like Materialize that are also Postgres compliant. There are systems like Rising Wave now, which are like built in Rust. Okay, Materialize as well. Kind of like, how are these systems different? What makes Rising Wave special? And kind of why would I choose Rising Wave, I guess?
So I believe that Rising Wave is definitely a number one stream processing system in the world today. I mean, if you want to edit something, for sure, I mean, you go ahead. I probably remove my sentence, but personally, I feel that's we the number one stream processing system at the moment. I mean, definitely Flink. Well, people use it for. I mean, if people have need to have let's say the Java API, for sure, yeah, go for Flink. But if you just focus on the SQL, then it's really hard for us to lose to any other systems. So we have people ask me why. I mean, if I talk about the design principles, well, then we have several things I want to highlight. The first one, actually, I think we have already mentioned, we are Rust based. I mean, Rust based, well, it's not like a design principle, but Rust always give the people the feeling that it's cool, and it's modern. Yeah, we attract a lot of early adopters, well, probably just because of Rust. And second thing here, that's as S3 as the primary storage, basically the coupled container storage architecture. And some people would say, okay, it's like a Snowflake-like architecture, right? So we started from day one, it's like a S3-based architecture. And if you check out some other systems, well, I mean, like Flink, well, they probably just recently announced that, or they were support that. But we actually have already adopted this architecture from day one, and basically baked it in production for over last 4 years. So there are a lot of like tricks. I probably could discuss later.
this is interesting, right? Because like this seems to be a general trend in like data management at the moment, in the sense that like when Snowflake came up, they were like the ones who invented in many ways kind of like, okay, like decouple storage and compute, using object storage as the lowest tier. And now you're seeing like these kind of, I would say, new age systems kind of using the same underlying principle to kind of disrupt that space. So Rising Wave for streaming, you had WarpStream, which was acquired by Confluent, kind of doing it around Kafka and so on, right? So like, I think it's super interesting how this dynamic right now is actually playing out throughout the entire data infrastructure stack. You have like Estuary, I think, who we had on the show, like Danny Palmer before, who are like building ELT tooling on top of S3. So I think it's like interesting how that's just happening everywhere, basically.
Yeah, we are definitely the first one to build so-called S3-based systems in the stream processing domain, even earlier than WebStream. We founded in 2021, and all the other systems were probably later. But essentially, there are a lot of like tricks, and I have to tell you that it's pretty transparent. So I have to tell you that was essentially over the last 2 or 3 years, so we were also thinking about whether we were doing the wrong design decision. And I can tell you more about that because for like we are stream processing systems, and S3 has two characteristics. Well, one is that's very slow. Second one is that's very expensive. So I mean, S3 storage is not expensive. It's just $23 per terabyte per month. But if you look at the access, well, how they charge, they actually are charged for get and put in all these operations. Well, I mean, that's super expensive. And essentially, it costs us a lot of money. And that's why we actually revisited whether we were asking us, okay, if we want to rebuild the system again in 2025, should we adopt the exactly same architecture? But essentially, we did a lot of optimizations, and now our answer is that for yes, if we build a system again in 2025 or even 2026, we'll stick with this architecture, and there's no change. But definitely, we probably will reprioritize some of the roadmaps. But essentially, it's super good, but for several reasons. The first one is that you never need to worry about the so-called the state management, because everything is in S3. I mean, specifically for tolerance, because everything is in S3. So yeah, we always trust S3. And secondly, is about the elastic scaling. In Rising Wave, we can achieve a second level elastic scaling. But for the other system like Flink, probably if the system whenever you want to do some elastic scaling, then that probably take hours. And essentially, they have,
which isn't very elastic if it takes hours.
So they actually have dynamic scaling, to be honest. Well, I mean, and I don't really want to hide anything, but like they do have dynamic scaling. But the issue here is that people do not really use that in adoption, because the people will think that I have the impression that it's not good for that. Which is true. But in our case, people do do the dynamic scaling all the time.
Gotcha. So Rising Wave itself is open source, right? Kind of an Apache license. At the same time, you also have a commercial offering. Take us through that, because it's such a common model nowadays, right? Like you have kind of ClickHouse doing something similar, a lot of other players in the space doing something similar. What is free? What is paid? When would I become a cloud customer, basically?
So for there are several things. Well, I mean, we have the cloud offering, we have BULC, bring your own cloud, and we also have on-prem. So on-prem, people will say, okay, boring business. Well, I mean, but we have to say that, so if you want to enter banks, all these kind of highly regulated industries, you actually have to be on-prem. We actually enter banks. We also enter the aerospace. So basically, if you, I mean, these industries, no.
Is Rising Wave running in space? This can become one of our questions. We had Hannes Mühleisen on, who said DuckDB is running in space. So is Rising Wave running in space?
I mean, it's definitely not in a satellite, but I actually don't know where they deployed, but I don't really
know. It might. Right? It might. For all we know, it might. Tell me something.
Yeah, probably.
Who would be the typical user? Where do they come from? They decide to build a new streaming system. Are they coming from a Snowflake? Are they coming from a Kafka, Red Panda? Do they come up from Flink? Like, how would you categorize that person?
That's a definitely good question. So we definitely do not really compete with Kafka. We do not really compete with Red Panda. We have super good friends with Red Panda. They're awesome, and we're definitely a good friend with WebStream, Pausa, right? WebStream Native and Confluent. So, but we do compete with Flink, directly compete with Flink, and so basically people. There are two options, two cases. The first one is that's okay. People probably new to stream processing and they want to adopt a new, system to process their streaming data. And then they do an evaluation with us. Well, they probably always can start with the easiest solution. And we are essentially the easiest solution. Why? Because we are Postgres compatible. That's it. Well, Postgres compatible. Challenge me, and you can go with Flink, but you learn the SQL, but in our case, Postgres.
You have the easiest. You don't have the hard, tough crowd here. It's like, since Firebolt is Postgres compliant, we're like all in. We're all in on your vision of the world. Like, everything should just be Postgres compliant.
Definitely, I think Postgres definitely help us a lot. People always love Postgres, and there's no such kind of headache in learning something new. Okay, and that's type one. So basically, people are new to stream processing system and they want to adopt a new system, and typically RainWave is probably the first choice. And the second option is that okay, they have already adopted the Spark streaming or Flink, and then they want to they feel some pain and they want to migrate. So a very recent case, which I'm super proud of, is that I could not share the company name because we signed an NDA, but it's a super big company, super big company, and they actually run a certain system, either Spark streaming or Flink. I could not tell you which one because there are some issues. And they actually run a system using 20K CPUs, 20,000 CPUs.
Wow.
And then they
Nice.
moved to RainWave and they only use 600 CPUs.
Wow, that's massive.
I had my PhD and I always challenge that kind of such kind of number, right? Well, how you can reduce the number of CPU from 20,000 to 600. How that's possible? So I also doubt that, but I actually talked to them, and so the reason here that's they're like state management. They do joins, multi-way joins, and so for all the other systems that's not scalable, but in RainWave it's super scalable, and we did a ton of optimization. So that's basically migration case. People feel the pain. They feel that's okay. They spend too many resources in the other systems, or it's probably, and sometimes people say, okay, I used to use Java, but it's so too slow. In terms of development, I want to shift to SQL-based systems. Or sometimes people say, okay, I don't really want to spend 4 hours in waiting for the Flink to get recovered from failures. Well, that was from a bank, and they got some issues with failure recovery, and they decided to the pivot, switch to some other systems from Flink, and that's all these kind of opportunities we got. Yeah.
Nice. That's very cool. So, switching gears a bit, like my LinkedIn feed recently has been full of actually posts by you talking about Apache Iceberg. So you're very good at kind of amplifying your content there. When I think of Iceberg, like I mainly think about it in terms of batch processing, right? Because this is what we're building it for. Take us through how Iceberg is changing the game for streaming.
There are two things I want to mention. The first one is Iceberg is batch, and people, they actually essentially compete with Snowflake, Redshift, BigQuery, whatever. And in the past, it's basically avoid a vendor lock-in because it's open table format. Well, as long as you adopt Iceberg, and then probably you could use DuckDB to use Firebolt to use any other system to query the data from there, right? So you are not vendor lock-in.
Didn't they say that on CSV files as well?
Yeah, I was in data council yesterday, and I know that's where you guys were also there as well. Some of the guys were also
Yeah,
there.
some of our folks from the Bay Area were there.
They actually did, and some other guys who I talked to, and they did mention, to be honest. Well, I mean, to be very transparent, it's not. Yeah, they did mention 5 out, and yeah. So basically, yeah, if you adopt Iceberg and there's no vendor lock-in, right? So you can use any query engine. So for stream processing, you asked me about okay, well, what's the relationship? Well, so basically in the past, well, I mean, our customers will essentially, after processing, they essentially send the data into Snowflake, BigQuery, or some other systems, Redshift. But nowadays, well, they think that, okay, I don't really want to be vendor lock-in, right? Well, let's send the data into Iceberg. So essentially, that's why Iceberg became, I think, our top 3 destinations of Rising Wave. Because, yeah, so in the past, it was like...
This is super interesting to me because when we think of Iceberg, we mainly think about it like as a source, right? It's kind of like, okay, like use a Snowflake managed table on Polaris catalog and Snowflake or something. Can we be more efficient in terms of query processing on top of that? What you're saying is that like for a streaming system like Rising Wave, the sync story is actually more interesting than the source story. So you're like the fabric that populates the Iceberg table. Is that fair?
That's fair enough. Yeah, we do, but we do ingest the data from Iceberg. We have the capability. But I mean, most people, I mean, sync the data into Iceberg because they are afraid of when they're locking and they just want to adopt the Iceberg. We see this pattern pretty obviously in all these kind of like enterprises. Their VP will say, okay, look, well, I don't really want to pay Snowflake. Yeah, sorry, Snowflake, but well, yeah, I don't really want to pay Snowflake too much money. I just want to shift. What's my strategy? Okay, let's do Iceberg. That's the thing. That's always a conversation we heard about. And yeah, basically the vendor locking is a big thing. And from a stream processing system perspective, definitely we need to think about what the destinations.
Staying with this destination thing, because I want to understand how a data pipeline like that looks, right? Like, would it be, I have this event stream, which is like, has like a just bunch of data. I don't want to ingest like the raw data, for example, into my Iceberg table, but use a streaming engine like Rising Wave to compute me 1 second averages over some metric. And then I ingest that into Iceberg. Like what is the actual data processing part that Rising Wave usually does in these data pipelines, basically?
So, like, well, there's always debate about ETL or ELT, right? Well, basically, if you send ELT means that's okay, let's just ingest all the raw data into my data warehouse, and the ETL means that okay, let's do some pre-processing before sending my data into data warehouse. I think in Iceberg world, typically people do ETL instead of ELT. Why? Okay. GDPR. The reason here, that's where like, I mean, you don't really want to send your PII data, right, but private data into your lake. Because well, if you send it into lake, then who to delete it, right? Well, I mean, that's always a challenge. And Iceberg is not super good at handling a lot of updates. So essentially, people actually need to delete the data or remove all the sensitive data before sending the data into Iceberg, right? In some other case, it will be like, okay, so people probably have data across the different regions, and they actually want to do some joins and aggregations, unions, well, before sending the data into Iceberg. And definitely people have the requirement of doing enrichment. So let's say that's where I have the clickstream, and I want to also have the, let's say, I don't know, well, I mean, user info, right? Well, and I want to enrich the data. Why people not do it into Iceberg? I mean, you can definitely do that as well using whatever system you want, right? To Spark, whatever. But the thing here, that's well, it's already a lake. Lake give the people the impression that well, it's historical data, and I don't really want to do a lot of like ETL inside of lake. So people do the ETL before ingesting into lake. But I think things will be changing because well, as long as well, people ingest more and more data into Iceberg, I believe that's what they were thinking. Okay, let's just do ETL inside of lake. I'm actually following the Iceberg spec more closely, and in V3 they actually have a feature called Iceberg Matrix View, and that's essentially for the ETL. in Iceberg. And I think Resume will probably become one of the first vendor that's a part of our Iceberg Materials View, because we are essentially ready. And we are just waiting for the Iceberg V3 got merged.
Nice. Okay, that's really cool. In that V3 spec, the MV definition, is that like, I mean, one problem is like SQL dialect differences between systems. How do they handle that within like the Iceberg spec?
Yeah. Like, well, in our case, it's just like Postgres, right? Well, we don't really care about for all the other dialects, right? So we just care about Postgres
They
because
might
for that
actually
here.
focus on the schema definition, consistency, and kind of how materials views commit versus on running on the SQL. I don't see any value in Iceberg trying to own the SQL, the business logic behind the MV. I can see how Iceberg can expand their metadata layer to support materials views, just from a materials view object kind of entity.
That's right.
But
That's right.
let's not get confused. Iceberg is not a processing engine here. It's a
sure,
metadata
yeah.
catalog that sits on top of Parquet. One of the things that people get confused with Iceberg is it opens up a lot of possibilities, but at the end of the day, they're still doing the same thing they've done before. What does change with Iceberg is actually the last mile of many data pipelines. So if you think about it, if you were using Snowflake before, to get data out of Snowflake into a different system, you needed to talk to the Snowflake team. You had to extend the Snowflake data pipeline to now export into Parquet. Now, let's not get confused again. Nobody does low latency exports from Snowflake. People do batch every hour, every day, a few times a day. They export their data to Iceberg. They export their data to an S3 bucket for the same matter. The difference is now they just write the end of the data pipe to Snowflake. So they kind of avoid having an extra export, right? They remove that extra export. But that extra export is not just about cost. It's about enabling the data to move to new locations. If the team that owns Snowflake is kind of the barrier within the company on getting right data, correct quality data to more systems, this is a problem. But if the Snowflake team, just like any other team, when they're done with an ELT or data pipe, doesn't matter, batch, streaming, doesn't matter. As long as you write it to an Iceberg table, you save a hop on the next stage of having to export it. So instead of exporting it, you import it. So people pull data from Iceberg table, and that changed the whole dynamics. But the same old problem still exists. Parquet is not designed necessarily for streaming format to do on-the-meter low latency out of the box, just like it's not designed to do low latency reads. It's not designed for many workload types, right? Scale out has challenges. So there's a compromise here. You can put Iceberg and get consistent metadata across systems. You can say, actually, I need multiple storage formats within Iceberg. I actually expect Iceberg to grow in terms of formats. Now that we have consistent metadata across systems, having a global format is less important now. If every system can read any format and everything is protected via Iceberg, then why not introduce extensions and improve formats so that actually workloads can run better through Iceberg? So Iceberg doesn't make workloads run faster. It makes different systems see the same data, and it makes different systems lose their kind of ownership over exporting the data forward to the next system. And I think that's kind of where we'll see a lot of innovation. I've heard someone telling a joke, which is kind of becoming something that kind of floats in the industry, that says, well, Iceberg was that intention of opening up and unifying metadata across all vendors, but it ended up just helping Databricks deal with all their own formats. So now Databricks will work for 2-3 years on Iceberg just to get their own data, and then like the 20 catalogs that they already support and they already sell some service to, now they can get all of them under one Iceberg. But still, Databricks data warehouse engine, which doesn't have much to do with Iceberg, is the highest selling product for Databricks. So I think for startups, it's a huge opportunity. I think Iceberg for Snowflake and Databricks is kind of basically a done game, right? The architecture is obvious. I do a dbt on Snowflake. I make sure it's getting written to an Iceberg so I can read it from other systems, and vice versa. But the real innovation around Iceberg will come from startups and will come from the kind of the new data ecosystem, from new companies introducing productivity tools on top of Iceberg. There's a lot of discussion on how to merge data behind Iceberg, right? A streaming system will need different compaction than a system that maybe does post aggregation. Who owns that? Who owns the tablet behind Iceberg? So a lot of open questions, a lot of opportunities for refiguring the ecosystem. And it's super exciting to see. I think in this show that streaming databases are here to stay. In fact, are getting so much stronger. And through Iceberg are actually getting much more attention. A normal person would not think about going through the streaming journey without a PhD. That's obvious. Like, you shouldn't even mention your PhD. Like, everyone would be surprised if you wouldn't have one. But opening up to Postgres, using S3, just figuring out consistency on streaming with that, you need a PhD for that as well. As you said, everything is connected. So it's amazing to see that complex systems like streaming, PhD grade systems, are getting the right treatment from the right startups. And I'm looking forward to see how Rising Wave and Firebolt can coordinate with more startups around that ecosystem, around that Iceberg ecosystem. Everyone wants to move out of Snowflake.
Yeah, definitely. Iceberg is essentially, people say it's called the single source of truth. So, I mean, like, we ingest all the data into one single source of truth, so that we do not need to think about, okay, where I have my data copy? Do I have my data, a copy of my data in, let's say, Postgres, or have another copy of my data in Snowflake, or have a third copy of my data in some other systems, right? They just sort of think, okay, likewise, it's the single source of truth. Iceberg is a single source of truth. And once you get a single source of truth, you can have all these kind of like engines, right? Essentially, my hot take, probably not hot take, but for an obvious take, that is for all the databases will become a query engine on top of Iceberg. So
I don't think it's such a hot take anymore. I think you're 2 years late.
A single source of truth justifies the source. The problem with data is not the fact that you move it around. It's not that you clone it and write it into a CPU register or RAM or SSD or a replica on S3. It's the fact that when it changes, there is no bookkeeping on that. So you need to backtrack the whole data pipeline, figure out in which step of the data change that source of truth changed. Now with Iceberg, you get a single, unified, consistent source of truth, and that can now trickle down anywhere. And any system that runs on Iceberg that supports transaction can support it. So you can time travel. You can do a lot of stuff you couldn't do without copying everything into a proprietary environment and then using it end to end. And having streaming on one end, just not one end, actually through the ELT as well sometimes, because sometimes ELT is streaming ELT. But then having that switch to a different engine, doing something else like a scale out group by, that becomes very interesting. And that monopoly over, you use everything, you use a single stack by a single vendor. The compute, the metadata, the workload, everything needs to be done by a single vendor. That claim gets shaken, and we'll see how that plays out.
Yeah. Look, the thing here that's so sometimes people probably. Yeah, like, I mean, Snowflake can ingest the data, probably can read the data. I mean, yeah, it's great, but sometimes people just have an impression like, I don't really want to get under locking, right? And all probably people are saying that, so I have some, let's say, specialized data type, and that which can only be read or probably write by certain systems. And in the past world, you probably need to build an integration between that kind of system with probably Snowflake. But now you don't need to do that, or just build an integration with Iceberg. So it essentially simplifies the development for a lot of vendors. Right. So, I mean, in the past, we probably need to think about, we do have integration with Snowflake, but essentially, if Iceberg came early, we don't need to do that. So, because the only thing we probably need to do.
You don't need to talk to Snowflake. Yeah. That's the beauty. If Snowflake writes to an Iceberg table, there is no lock-in. The data is not locked behind the Snowflake wall. It is actually completely open to anyone that can scan or write or read from into Iceberg. Absolutely.
Yeah. In the past, well, it's like, okay, I need to think about it. Okay, I mean, from a vendor's perspective, okay, I need to think about it. Okay, how to maintain the pipeline to Snowflake, how to maintain the pipeline to integration with Redshift, how to maintain the pipeline integration with BigQuery. Nowadays, no. I don't think you worry about that. But I mean, even though we have already hit that, but these days will mainly focus on Iceberg.
Perfect. I think that's a beautiful summary to actually end our show today. Thank you so much for being kind of on. I think you guys are running a bunch of meetups in the next couple of months. I know we'll be kind of participating in some of the European ones. So listeners, kind of take a look, kind of go to some Rising Wave meetups. I think it's going to be a blast. It was great having you on the show.
Sure, yeah. I mean, we have we do have I will be in Europe in May and June, and hopes to see you there. And I know that's where we have a lot of collaborations. And yeah, if people are interested in either Rising Wave or Fireball, just join us.
Lovely. It's going to be fun.
Amazing.
Thank you for being on.
All right. Thank you.
The Data Engineering Show is brought to you by Firebolt, the cloud data warehouse for low latency analytics. Get $200 credits and start your free trial at firebolt.io.